Okay, as I said, today we'll begin our discussion of capital investment decisions. Mainly, how much to invest, where to invest, how to invest, the whole process of investment and evaluation of projects will be discussed for the next 3 weeks. We will be covering 5 sections today and on Monday: net present value, payback, the discounted payback, the average accounting return, and the internal rate of return rule. And of the 5 rules I showed over here, I am not going to talk about 9.3, but it is for your own reading. You read it, and that is included in the midterm coverage. 9.4, if you want to read it, but it is not going to be on the midterm exam. Okay? And up to this 9.4 is midterm exam 2 coverage. Okay? 9.5 will be deferred to the final exam. Okay? We will not have time to cover the internal rate of return rule today. Okay, there are a few important concepts that you need to understand. So for the first half of today's class, there is no math, just talking, discussing, and if you have any questions, please raise your hand and ask me. A few definitions. Number 1 is a project. What is a project? A project is a basic unit of our analysis for the next 3 weeks. Capital investment decisions is essentially involving around a project analysis, project evaluation. Okay? A project is a set of economically dependent opportunities, and we talked about opportunities last time. So economically dependent opportunities mean that all the opportunities where the cash flows from them are interrelated. They are interdependent. So one opportunity goes well, other opportunities will do well. One opportunity does poorly, other opportunities will do poorly. So these opportunities are put together to create something called a project. And project is the basic unit of our analysis. Capital budget is a pool of long-term projects. These projects, they are put together into one budget. And that budget is called capital budget. Okay? So a capital budget is a pool of long-term project, and the management of this capital budget is called capital budgeting. Capital budgeting involves plan, do, and see, or planning, execution, and evaluation of a project. Plan, do, see functions of the company's investment activities as opposed to cash budgeting. Management is nothing but planning. Unless you plan well, you are not going to get anything done. Planning is so important. Then executing. You have to execute the plan. Even if you make a fine plan, unless you execute it, unless you actually spend money to do it, planning doesn't do any good. Okay? Execution is needed. And once you execute, there will be results. And you have to evaluate the results. And once you evaluate, the evaluation results will be considered in planning mode again. This is feedback rule. Feedback back loop. And this is management. This feedback loop is applied to capital budget. That's capital budgeting. So capital budgeting involves planning of capital budget and executing of the capital budget, actually spending money for the projects, and evaluation of the results and considering or using the results to improve the capital budget again. So this whole loop is considered capital budgeting. Okay. Project evaluation is critical. In the capital budgeting, project evaluation is very, very critical, and it is perhaps most important part of capital budgeting. Project evaluation is critical because for four major reasons, and I'm going to emphasize this again and again. Project evaluation is so important, and that's why I spent this much time to talk about it with you, and that's why I am asking you to spend much time to study this thing. Okay? Project evaluation is so critical because, number one, project acceptance is irreversible. Once you accept the project and once you invest, it cannot be reversed. Once you invest your money, you cannot undo it. You cannot undo it. Once you build a dam to block the flow of a river, then the landscape is changed forever. It cannot be reversed. You cannot undo it. In the case of financial investment, you make an investment, oh, I made a mistake, and you reverse it. It is possible with financial investment. But capital investment? No way, no way. It's not possible. Once you invest it, then you are done with it. You cannot reverse it. It's not reversible, and that's why you have to spend much time and effort to evaluate properly. Number one, capital investment is irreversible. Once you dig your ground and then build a subway system, you cannot undo it. You cannot undo it. Once you build a harbor near Incheon, you cannot undo it. Once you build it, that's there forever. Once you build a nuclear power plant, it will be there for 60, 70, 100 years. You cannot reverse it. You cannot regain the original shape. Okay? So irreversibility, that's number one. Number two, typically capital investment involves long-term consequences. The effect will be felt for long time period. Long-lasting effect will be the result of a capital investment. It's long-term consequence. Once you make a decision, and that the effect of the decision will be felt for a number of years, as short as 3, 4, 5 years, and as long as 30, 40, 50 years. Building a dam, it's a 50-year project. It will be there for 50 years, and perhaps longer. So consequences typically very, very long-lasting, and it involves large amount of capital. It involves large amount of money. Some of the national projects involve billions of dollars. That's a huge amount of money. So irreversible, long-lasting consequence, and typically involves very large amount of capital committed. Plus, flexibility of your future decisions. Investment now limits flexibility in the future. Once you have a piece of land, and if you use that piece of land to build a hospital, you cannot use that land for something else. When you have a plant that has capacity of certain magnitude. And once you invest additional the capacity, then because of that, the unused capacity cannot be used for something else. Your flexibility in the future will be limited because of your decision to accept the project. So limitation of flexibility in your future decision making is also a very important element of capital investment decisions. Okay, irreversible, large, long-lasting, and flexibility, a limitation on flexibility. Okay, these four are the reasons why capital investment, project evaluation is so critical, right? And that's why I spent so much time and I move slowly to discuss this thing with you. There are two kinds of decision making with project evaluation. This page is not, by the way, in your class note that I uploaded. I will upload the revision of the note this afternoon. I revised it. I added this page 9 o'clock this morning. So, okay. There are two kinds of decision making with project evaluation. Number one is accept or reject decision. You either accept a project or reject a project. If it is a good project, then you accept it. If it's not a good project, you reject it. Okay? Accept, reject. This is straightforward, right? The other kind of decision making is ranking decisions. Ranking. You have number of projects. Sometimes they are competing projects. And you would like to rank them in terms of their priority and prioritize them. Okay? So ranking decisions of mutually exclusive projects. Mutually exclusive means that any two projects are mutually exclusive if acceptance of one precludes acceptance of the other. You cannot have both. Okay? The projects are competing with each other, then they are mutually exclusive. All right? Ranking is also needed when a corporation needs to allocate a limited amount of investment resources or when budget is limited. Yes. Many companies have budget limit for the year. Okay? We are going to invest 10 billion US dollars. That's 10조 won. A lot of money, but for large companies, that's not really a lot of money. But that will be allocated to many different projects. And sometimes there may not be enough. So capital needs to be allocated. And when allocating your capital, you have to have some priority attached to the project. You cannot have them all. So prioritize them, rank them in terms of your preference, and then invest up to the level where you have available resources. Questions? Okay. Now, before we do that, let me write down a few project evaluation decision rules. There are essentially 5, 6, and perhaps more decision rules, but we'll do the following in this order. Net present value. In short, that's called NPV rule. And this rule suggests accept if NPV is positive. Okay? If NPV is positive, then accept. And rank in the order of NPV magnitude. The larger NPV first. Okay? The project with larger NPV will be preferred over others. The second rule is payback period, or we use the abbreviation of PV, payback period rule, and except if payback period of a project is less than or smaller than some target predetermined payback period. Say you would like to recover your initial cash flows within 3 years. If your project can be recovered in 2 years, then the project is a good one. But it takes more than 3 years, then you do not accept the project. Rank in the order of payback. The shorter one first. Okay? Shorter payback period one first. The third is internal rate of return. IRR rule. Internal rate of return is except if internal rate of return of your company is larger than equal to cost of capital, or R, or big R, depending upon which book you use, and rank in the order of IRR. Larger IRR first. IRR is the rate of return on investment on the project. We'll talk about how to calculate IRR, how to calculate the net present value, and so on shortly. And the last one is profitability index, or PI rule. And PI is essentially total value of a project divided by initial investment. So if PI is larger than 1, accept. And ranking, rank in the order of PI. And I'm going to talk about net present value rule, payback period rule, and IRR rule, and then profitability index rule, and anything else for you to read and comprehend. Out of 4 different methods, 4 different rules, which rule to use? Which decision-making rule shall we use? Depends upon whether or not each and every rule satisfies this set of criteria. Good decision criteria involve the following. We need to ask ourselves the following questions when evaluating capital budgeting decision rules. Number 1, does the decision rule adjust for the time value of money? Does it account for or adjust for the time value of money? Okay? Does it involve discounting? Discounting is essentially to adjust for the time value of money. And does the decision rule adjust for risk? The cost of capital. Does it use the required, the risk-adjusted cost of capital or risk-adjusted discount rate? Does the decision rule provide information on whether we are creating value for the firm? Okay, these 3 are the critical questions we ask before we choose any of these rules. Now, let's start with the net present value rule. Somehow, the the person who made these slides did not use mathematical notation. Students may have complained that we have too much math in this class. So I try to limit the use of math for today's class, but I have to write it. Okay? NPV is equal to present value of cash inflows minus present value of cash outflows. It involves present value of cash inflows. A project involves future cash flows. Once you make an investment, and you will receive future cash inflows. So future cash inflows, the present value of it you can calculate. And compare that to the amount of investment that you are making. Right? So mathematically, for a typical project where you have initial investment outlay and future cash inflows, summation t starting from 1 through t, and capital T is the duration of your project. Cash flows, and definition of cash flows will be discussed in 2 weeks. Cash flows at time t divided by 1 plus some discount rate r to the tth power minus initial investment outlay. This is initial investment outlay. Well, initial investment, the amount of money that you give up in order to undertake this project. You have to spend this money. You have to invest this money. Then you get future cash flows, and the authors of the book, and I also ask you to take it for granted that this expression is a good approximation of the market value of cash inflows. Or, market value of the project. Take it as given, okay? Or let me use the phrase that the late Nobel laureate Merton Miller he said, if you grant me to use this expression, market value of the project. Okay, market value of the project is defined to be the present value of all the future cash flows from the project. Okay? So you make an investment. Invest ISABO. And you get cash flows 1, cash flows 2, and cash flows time t. So look at me very carefully. When you accept a project, when you undertake this project, you are giving up your financial resources of ISABO, I0. I0 is the amount of financial resources that you are giving up. You are spending for the project. If you spend this money, then you are entitled to the cash flows that will ensue, that will be generated over time of the project duration. So you are exchanging today's resources with future resources. You are giving up today's resources in order to get future resources. So the amount of today's resources that are given up should be compared to the resources that you will have in the future. But resources you will have in the future are spread over time into the future. So you would like to have a single number called the market value. So market value of these resources should be compared with the amount of money that you are giving up. So obviously, the amount you receive, the value that you will receive from the project should be greater than the value that you give up. This is the value that you receive, and this is the value that you give up. And if the value that you receive is greater than the value that you give up, then you are better off. And that's positive net present value. If then the present value is positive, the value that you receive, the value of the project is greater than the value that you give up as investment. Are you with me? Okay? That's the idea of the net present value rule. The difference between the market value of a project and its cost. How much value is created from undertaking an investment? The first step is to estimate the expected future cash flows. These cash flows you have to estimate. The second step is to estimate the required rate of return. What discount rate should you use? And thirdly is to find the present value of the cash flows and subtract the initial investment. Find the net present value. That's the idea of net present value rule. Here's a case. Okay. Year zero, it requires the sacrifice of $165,000. That's the amount of investment. This is initial investment. And year one, you get $63,120. Year two, $70,800. Year three, $91,080. And your required return for assets of this risk level is 12%. This discount rate is 12%. That is adjusted for risk. That is commensurate to the risk of this level of that's adjusted for this risk level. If NPV is positive, you accept the project. Positive NPV means that project is expected to add value to the firm and will therefore be increase the wealth of the owners. Since our goal is to increase the owner's wealth, NPV is a direct measure of how well this project will meet our goal. And here's a computation of it. Forget this calculator thing. Look at the top line. 165,000. That's the initial investment outlay that is subtracted first. And then you add discounted value of the first year cash flow of 63,120. Discounted cash flow of the second period cash flow, 7,800, and third year cash flow, 91,080 over 3 years, and that will give you 12,627. So you give up $165,000 today, and you are getting 165,000 plus 12,627. This is the net addition to the value of the firm, net addition to the wealth of shareholders because of the acceptance of the project. Are you with me? Okay? Is it okay? Understood? Okay. Now, whether or not this decision criteria, decision rule satisfies the decision criteria test. Does NPV rule account for the time value of money? Yes, it does, because it involves discounted future cash flows. Does the NPV rule account for the risk of the cash flows? Yes, 12% is adjusted for the level of risk. Does the net present value rule provide an indication about the increase in value? Yeah, by definition, NPV is the difference between the market value of a project and the initial cost. So the bottom line is, should we consider the net present value rule for a primary decision rule? And my answer and your textbook answer is yes. You should use the net present value rule. Okay? So we are using the net present value rule as a standard. Okay? As a standard. However, actual corporations do not necessarily use the net present value rule all the time as the most important decision rule. I am on a corporate board of a couple of companies, and they had board meetings lately, and we were discussing the project acceptance. And one project I saw was having the net present value of very large amount, 20 million US dollars. So it's in Korean won, about 200억 won. That's not a small project. The present value is that large. So I said, let's accept the project. I vote for the acceptance of the project. But the documents that I saw had net present value in the bottom. The top line was internal rate of return of 21% and payback period of 3 years. Okay, payback 3 years, internal rate of return of 21%, and NPV was at the bottom. Okay, that shows you how the corporate practice is different from what we teach in class. And there are several reasons why. But let me hasten to say that the net present value rule is a good standard because it is very consistent with economic theory. Right? Market value of cash flows received being compared to the market value of cash flows that are spent. So you receive cash flows and you spend cash flows, and the market value of your received cash flows is greater than the market value of your spent cash flows. So this NPV rule is a very consistent conceptually and theoretically. Okay, this one. Let's move to the next one. Payback period. How long does it take to get the initial cost back in a nominal sense? How long does it take to recover your initial investment? Okay. If and when, and it's not if, just when you are employed by a company in some years, 2 or 3 years, you get a job and you're employed. And you are working in the treasurer's office to find the net present value of the project. And you bring the result to the CEO's room or CFO, report it to the CFO. Mr. CFO or Ms. CFO, our new project has net present value of 12,000 something. And immediate response from your boss is not okay. Immediate response will probably be, how long does it take to recover our investment? We are making an investment of 165,000, and how long does it take to recover the money? The faster you recover your initial investment, the better off you are, especially in a world full of uncertainty. You have large amount of uncertainty around you, and you would like to get your money back as soon as you can. So sometimes that gets the priority rather than the present value. Net present value is important, I know for sure. Using my head, I know net present value is a good decision criteria, but my intuition tells me, how long does it take? If you say, oh, it takes about 5 years, and immediate response from your boss is, oh, that's too long, that's too long. 5 years is like eternity. Okay. So, a payback period rule. How long does it take to get the initial cost back in a nominal sense? Computation is to estimate the cash flows, subtract the future cash flows from the initial cost until the initial investment has been recovered. And decision rule is, as I wrote, accept it if the payback period is less than some preset limit. So computation of the case in hand. Assume that we'll accept the project if it pays back within 2 years. 2 years is the payback period, preset period. Year 1, you get 63,120. So out of $165,000 of initial investment, you get 63 back. So after 1 year, you still have 101,880 to be recovered. You still have to recover more than 100,000. Year 2, you receive 70,800. So even after year 2, you still have 31,080 to recover. Okay? Year 3, finally, you recover. You still have to recover 31,000, but you get 91,000. So it takes about 1/3 of a year to recover your remaining investment. So the payback period for this case is about 2.3, maybe 2.4 years. And that's larger than 2-year preset limit. So this is not a good project. Even though net present value is positive, this is not a good project to accept. Are you with me? Okay. Does the payback rule account for the time value of money? No, it doesn't, because there is no discounting involved. Does the payback rule account for the risk of the cash flows? No, it doesn't, because there is no discounting. Does the payback rule provide an indication about the increase in value? No, it doesn't. So it doesn't do anything, except that it is so. Simple and easy. I didn't write down EASY. I said easy. It's so easy, and it's so simple, and it's so intuitively appealing. Okay. Okay, there are advantages. Easy to understand, adjust for uncertainty of later cash flows, bias toward liquidity. Okay. Read your textbook and try to understand what they mean. Disadvantages: ignores the time value of money, requires an arbitrary cutoff point, ignores cash flows beyond the cutoff date, biased against long-term projects such as research and development and new projects. Okay, you are responsible for all that. I'm not going to discuss further. Let's move to the next. A discounted payback. This is overcoming some of the shortcomings of the payback period method. You are responsible for this, but I'm not going to talk about it. And I will forget average accounting return and move to internal rate of return. Okay, internal rate of return, I think I'll have to write the definition of it. IRR is a rate. It's a rate of return. It's a rate. It's a percent rate. IRR is the rate of discount. It's a discount rate. Discount rate that equates NPV equal 0. So it is, if you write it down, T starting from 1 through big capital T, cash flows at time T, and if you use IRR as a discount rate, it will be 0. Net present value, when using the IRR as a discount rate, net present value becomes 0. Put it differently, the rate of discount rate, where the present value of cash inflows is equal to the present value of cash outflows. Present value of cash inflows is equated to the cash outflows. That's called the internal rate of return. You saw the internal rate of return of the example. Okay, the example, you saw the net present value of the example. When net present value was 12, when the excuse me, when the discount rate was 12%, net present value was positive, right? When discount rate was 12%, NPV was positive. Now, if you raise the discount rate to, say, 15%, what will happen to the net present value? Will it be smaller or larger? It will become smaller because your denominator becomes larger. Therefore, the net present value will become smaller. If you push it higher, until you find that net present value becomes 0, that discount rate is internal rate of return. That discount rate is internal rate of return. You've seen this concept before when you calculate the yield to maturity of a bond. The same concept. Right. Definition. IRR is the return that makes NPV equal 0. Decision rule. Accept the project if the IRR is greater than the required return. Okay. Computing the IRR. If you do not have a financial calculator, then this becomes a trial and error process. Calculator, forget that. Let's look at this graph. Okay. This graphical presentation is much better. Okay. At 12% discount rate, NPV was about 12,000, right? If discount rate is 0, then NPV is 60,000. So as discount rate becomes larger and larger, NPV becomes smaller and smaller. That's obvious. That's because of the formula. Right? Formula is constructed in such a way that the larger the discount rate, the smaller than the present value. 12%, NPV was 12,000. 12,000. 14%, it is still positive but smaller. 15%, it's still smaller but positive. 16%, it's a little bit but still positive. Go to 17%, what happens? NPV becomes suddenly negative. So you know that IRR is between 16 and 17%. So you trial and error, give a different rate here and there, and you will see that IRR is 16.1%. At the IRR of 16.13%, the net present value is equal to 0. Right? Do you get it? If you have a financial calculator, it is so easy. You can have a number, something like this, very precise. What good does it do to be precise about it? Okay, it's about 16%. But if you don't have a financial calculator, it will be a chore to do it. Okay, trial and error, trial and error. And this is where a lot of my friends back in the 70s, they decided against majoring in finance. They hated finance because of computation. I did that too. I hated it. And I hated my professor who assigned this kind of question. It's an irony that I became a finance professor. Nowadays, you have a financial calculator, you have a spreadsheet, Excel, you have many different ways of computing IRRs. So don't give up. Okay, don't give up. It's so easy. Try to understand the concept. In the exam, I'm not going to write a problem that says find the internal rate of return of this project. No, I'm not going to do that. I will not do that. But I will test whether or not you understand the relation between net present value and IRR. When net present value is positive, IRR is greater than cost of capital. Okay? NPV is positive. That means this range. Okay? This range. that range is always the case. IRR is greater than required rate of return R. So long as IRR exceeds the cost of capital R, net present value is always positive. So you accept a project when NPV is positive or internal rate of return is greater than the cost of capital R. Okay? So in terms of in the case of accept or reject decision making, IRR rule and the net present value rule, they give the same answer. Okay? Whether you use the net present value rule or internal rate of return rule, you get the same answer. Accept the project. The problem begins to occur when there are two projects, competing projects. One has greater IRR but smaller net present value. The other one has larger net present value but smaller IRR. And there's potential conflict. If you use IRR rule, A is preferred to B. If you use the net present value rule, B is preferred to A. Then how can you reconcile that? That's a question that we'll deal with on Monday. I'm going to discuss this on Monday. Again, your exam coverage stops right before our discussion of the net present, right before the discussion of the internal rate of return, IRR. Okay, so right before that, section 9.4, that's you are responsible for the midterm exam, midterm 2, and internal rate of return will be covered in your final exam. Okay. Again. That's all for today, and there will be a review session on Monday. Well, there will be a class on Monday. So after Monday's morning class, in the evening, 6 o'clock p.m., we'll have a review class in a room that I will announce on Monday. And you have your exam on Wednesday in a different classroom. Exam will be about the same format of around 15 multiple choice questions and problems, and 4 essays and problem questions. And you will be given 70 minutes. And I'll be proctoring myself, and I'm not I will answer all the questions you have. So don't try to memorize all the formulas you have. If you need a formula, ask me. I'll give you the formula. Okay? That's all for today. I'll see you on Monday. And don't forget that we have a distinguished lecture series on Thursday. So mark Thursday afternoon, 5 o'clock p.m. You have a special lecture. Okay, that's all. Thank you.